Hello, we're here to talk about example 5.8, and we're going to be doing binomial probability calculations within Excel. Binomial distributions are much similar to normal distributions, except where a normal one is continuous, a binomial is digital. So what does that mean? What I have here, this picture that I'm showing, is probably the easiest way that you can have to see what a binomial distribution is, and this is a pair of dice. Dice are great, especially for learning probability. When I was a young, a little kid playing around with my aunt's nursing textbooks they were doing with probability, this has always fascinated me. And once again, dice are an easy way to see it because, especially with a six-sided die, you have a 1/6 chance of the side to show up. Now, in a binomial, we have these distinct, discrete possibilities that can happen. You can roll a 2, you can roll a 3, you can roll a 4, da da da. There's nothing between 2 and 3 because you have this discrete number, 2, 3, 4, all the way down. And so this is just the distribution of all the different numbers that you can throw. You have a 1/36 chance to throw a 2 or a 12, which are the most uncommon throws. You have a 1/6 chance to throw a 7 because you have 1, 2, 3, 4, 5, 6 different combinations that can come up. And so that's how we get a distribution like this. So just wanted to throw that in there, a little bit more about what is a binomial distribution. So the problem that we are dealing with today is suppose that we have 100 identical batteries and we're going to insert them into identical flashlights. Each flashlight takes a single battery, and after 8 hours of use, a given battery is still operating with a probability of 60%. So that means 40% of the time it's failed. And so what we want to do is we want to figure out couple of the probabilities of some of these situations happening. So this is going to be very similar to our normal distribution, except we're going to use a binomial distribution. So exactly 58 successes. So the probability that X is going to be 58. So this is a binomial distribution. And how do I know that? Because there's only 2 states that the battery can either be on or off. And since it can only be on or off, when we go to count things up, we're going to end up with whole numbers because even if all 100 of them are off, it's 0. If one of them's on, it's going to be 1. So that's 99 failed. If 50 of them are on and 50 of them off, well, that's going to be, we've got 50. There is no 48 point something. So it's not a continuous function. So the probability that we will just have 58 of these things. And as I said, we're going to use the function, so BIO, and you can see that we started putting together binomial, and I spelled it wrong because there's an N in there. And so, once again, we have a bunch of different binomial down here. So binom.dist, disrange, and inv. Well, we're going to go with dist, so returns the individual probability in that distribution. So it's going to ask for number of S. So that's the number of the sample. So in this case, that would be 58. So the number of trials. How many times are we running this distribution? How many times are we checking the batteries? Okay, so we're going to run this test 100 times. And so what's the probability? So now let's use the cell. What's the probability? Since we're trying to figure out successes, the probability is going to be our probability of a success each trial. Okay, cumulative or probability of the mass function. What does that mean? Basically, this would be if I was looking for 58 or less, just like we were doing in the normal distribution, that would calculate up the probabilities of all the other ones, and it would add that all together. We're actually going to go false on this one because we want to know exactly 58. So taking all that into account, we have a 7.4% chance that we're going to get exactly 58 successes. Okay, so the next one is no more than 65 successes. What is that? Well, that's going to mean that our probability is going to be less than or equal to 65. So we're actually going to, I'm going to come up here and I'm going to lock those two in because we're going to drag that down. So it's actually the exact same equation. Small difference though. First of all, let's change this to 65. So the chance that we'll have exactly 65 is 4.9%, but we want 65 and less. So instead of being false, we're going to change this to true because we're going to make it cumulative. And 1 is true. And so there we go. There's an 86.97% chance that we will have no more than 65 successes. Okay, so now we want less than 70 successes. So if I do this, and the thing is it's not putting it at 70, because that would be 70 less than or equal to, but as you can see over here, we want less than 70, which means that we need to calculate it at 69. Because there is no 69.9999, because it's a binomial distribution. There is no continuous things between 69 and 70. So we set that to 69. That will be less than 70. 97% chance that will happen. Okay. What happens if we have at least 59 successes? Well, that one's a little bit different because this is going to be on the other side. So we want to know 59 or more. And so what we're going to do is we're actually going to take this one here, copy and paste that down. So what is this? Remember, this is our chance that we are going to have exactly 58. And so if I change this, that's our chance that we're going to have 58 or less. So if I want 59, that would be 1 point higher. And so if I take 1 and subtract all the chances that it's going to be 58 or lower, that will give me that'll give me the number that'll be at least 59. Because this calculates here what is the chance it'll be 58 or lower. If we want at least 59, well, what's the probability that at least 59 or 59 will be? It'll be 100% minus the chance it'll be less than 58. Okay, so greater than 65 successes. So this was no more than 65 successes. So we're just going to move that down. And so if this is the chance that it will be less than 65, well, the chance that it'll be greater than 65 will be 100% minus the chance that it'll be less than 65. So there is a 13.03% chance that it will be greater than 65. Okay, and so between 55 and 65. Okay, so how do we calculate that out? Well, we can sit there and we already have calculated out all this stuff before, but let's go. So we're going to need to take what's the chance that we can have 65 successes. So we'll just go Control V. So that is our chance that we're going to have 65 successes. And we're going to subtract from that basically 54. Because we don't want to do 55 because we want to know between 55 and 65. 55, there, since it's not continuous, we have to go one lower than 55. So we'll subtract. We'll take the binomial distribution of 54 of our number of throws minus our probability on each one of those. This would give us the probability of 65 or less. We'll subtract from that the probability of less than 55, and that difference between the two of them, and I forgot to add in my 1. The probability that it's going to be between 65 and 55 is 73.48%. Okay, so let's go and find the 95th percentile. We're going to trial and error it because we are going to use our binomial distribution and try to find out what's going on. So, binomial distribution. You're probably sitting there going, but we have an easier way of doing this. This is true, but we'll get to that. So the number that we're going to be looking for is, okay, what's the chance that I got 65? Why am I doing it this way, by the way? Because I know from up here, 65 is 86%, 70 is 97%, so that 95th percentile's got to be in between the two of those. And so then we're going to take our number of trials, we're going to lock that in. We are going to take our probability, we'll lock that in. And yeah, we want it to be cumulative, so we'll make it true. And so now I'm just going to drag that down, and there we go. So our 95th percentile is, well, we got 67 and 68. 95 lays in between the two of those. So that would be our 95th percentile. Why don't we have an actual 95? Remember, it is a discrete thing. So we don't have a continuous point in between those that we can look at and go, this is exactly where 95 would be. Now we can't call 67 the 95th percentile because it's not. It's lower than the 95th. 68 is above. So what do we do if we want to not have to do that? Well, once again, we have the inverse function. So binom.inv gives us our thing. And actually, if you look at it, returns the smallest value which the cumulative binomial distribution is greater than or equal to the criteria. And so our trials, our number of trials is 100. Our probability is 68. And then it asks for our alpha. Well, our alpha is our percentage. And if we go back and look at the text and talk about things, we have all that listed down. So we go and calculate it this way. It tells us, hey, 68 is the minimum value that we've got that will give us the 95th percentile in a binomial distribution. And there we go. So until next time.